Greetings, everybody. There's couple other people coming in here. We're going to kind of jump right into it today. We have a kind of a presentation that Don Lafreniere and myself are going to do, focusing more on the data infrastructure and how to build data. So it's a little more technical than the previous chats. Um, my fellow team members might stop me if someone throws something in the chat that I need to address, and or Don as he goes. Um, but we're going to focus on that talk for like the first two-thirds of things here, the first little over half. And then after Don and I are done presenting, we're going to jump into a breakout room to deal with the homework that we set for you guys, some example projects to look at. And that's also going to be time for discussing the content of this talk as well. So thinking about your data, how to build your data for your deep map, and hopefully kind of pushing the boundaries while we're doing it. So without further ado, we will go to the next slide and start moving through our first part of the discussion here. This is a six-parter, but the first four parts are kind of what we're going to be talking about. And then, as I said, we'll move into this evaluation of examples in breakout rooms and discuss those sorts of things. And at the very end, we'll have a super quick wrap up before we end for the day. So next slide, we will get straight to it. What we're going to start with here is primarily the technical definitions and the components of a historical spatial data infrastructure. So the container for your project's data, which really defines your universe in time and space that you're going to be working within. Next slide. I'm not going to dwell too much on this sort of prehistory of it because we've talked about this in our previous webinars. So generally speaking, to kind of summarize what's on the screen here, building a deep map requires some kind of digital infrastructure. It needs to be able to contextualize things in space and time. And what we're looking for is something that is flexible and scalable, something that accommodates the maximum variety of data. It can accommodate small and large data sets. So flexibility and sustainability on top of all that as well, something that is easy to build, maintain, and will survive going forward. Next slide. And we will also put this up as with all of our webinars, so you can take a look at these slides later. But when we built our deep map, the general approach was kind of building on initial spatial data infrastructures that were applied to different kinds of data. So there was a precedent for this. The Minnesota Population Center has essentially built something like this for census data and other demographic data. It's something that is used in urban planning, various kinds of planning, and large-scale data management by institutions. So that's your basic spatial data infrastructure that we have adapted for the purposes of building deep mapping. And again, that flexibility, robustness, scalability is kind of at the center of all that. Next slide. So let's get to the actual HSDI. What is it in pure technical terms? At its core, an HSDI is a series of databases and digital data sets. So it is a way to use existing database technology, enterprise scale database technology, to store the kinds of information we need to build and use a deep map. This is inherently always going to be spatial data, so it has some kind of coordinates attached to them. It has attribute data, so metadata and actual attributes that explain things about that particular data, or in the case of census data, the attributes are the core of the data itself. And that hosting on an enterprise style database, which underlies so much of our e-commerce and mapping apps and all kinds of things that we use on a daily basis in our lives, allows us to store really large amounts of data that can interact with each other, both spatially and through those attributes. In our case at Michigan Tech, we are using an Esri ArcGIS Enterprise/Portal implementation. That's the software that underpins our historical spatial data infrastructure. There are other software packages you could use to build something that's more or less equivalent. And we use some other add-on software here and there that our database specialist, Ryan Williams, and really kind of focuses on kind of greasing the wheels and making all these things work together. But at its core, it is essentially an off-the-shelf piece of software that we've adapted. And on the right, you can see this image, which sort of attempts to summarize in diagrammatic form what an HSDI is and how we connect with it. So again, in that gray square, we have our databases all linked together in one implementation that's hosted, in our case, at Michigan Tech. And you can have lots and lots of these different data sets, census data and other historical records. You can have all kinds of cartography and imagery that are in there. These are all spatialized, so they've been geo-referenced. You can also have your 3D, AR, VR, other kinds of digital products, born digital or digitized, in there as well. And so all of these exist in some form of spatial database format, which is how they're connected together. You can either access these directly as a database to do research, or you can access them through some kind of more user-friendly middleware software, like the Key in a Time Traveler in our case, that allows somebody without database experience or without digital research experience to actually investigate, identify, and interact with these sources. So that's kind of essentially, when we talk about an HSDI, this is what it is. It's a linked series of managed geodatabases, spatial databases that are accessed in different ways. Next slide.
So one thing I just want to provide a little more context to this. We're going to be going over in some detail for those who are going to be able to join us in July on exactly how to construct this HSDI, as well as there's a bunch of open source utilities that are sort of linking these various spatial databases together, and which we're not getting into today because it's too technical for this type of workshop, and not everybody needs to know how to do that. Only probably a select few on each team. So just know that if this feels like, wait, there's a lot of missing pieces, we're going to go through this in great detail when we're all together in July. Okay.
Yeah, thanks, Don. And yeah, to add to that, we are going into some detail today, and I want to give you an overview of what the construction of an HSDI is and how we built ours to a certain extent. But this is intended to kind of get you thinking about what kinds of areas you want to focus on and challenges and things like that, rather than be an actual walkthrough just today that afterwards you could build one. We're going to do that, as Don said, in person and going forward. So we've established our set of databases as the essential HSDI itself. But within that, we've come up with a couple ways of organizing the data that hopefully will be helpful for you. It certainly was for us in terms of reconstructing past environments and present environments as well. And this is this linked environmental stage approach that we're illustrating here. So this is something that Don Lafreniere originated about 10 years ago, and we use this concept to build the several HSDIs and deep maps that we have put together so far. And the idea here is this is more of a conceptual framework. You have your databases, but how do you organize all that stuff? Well, you think about the sort of human meanings and themes behind different kinds of data, and you organize them into certain categories, what we're calling stages here. And so we have broad categories like the social environment and built environment stage. So what is the physical environment, the physical human built environment? What does it look like? What is it constructed of? Those kinds of data sets can go into that stage. What is the social environment? How do we reconstruct the social environment? What data sets do we need to do that? That one falls into another environment. And there's other ones here that, again, meet some broad themes that you might conceptually want to organize around, like the natural environment and industrial environment. In our case, we're in a legacy mining landscape, so that's important to us. And these scenes are broken down by longitudinal divisions. So in our case, we're trying about every decade to build these robust stages, although things can bleed, one way or another. Next slide. And so this is an area, for example, where conceptually you want to think about what kind of stage you might want to build. What is a broad thematic category that is essential to what you're trying to do that you can sort of focus your efforts around? But it also helps you kind of phase things out. What is another stage that you might not want to build initially, but you do think is important to build down the road? And how would that affect overall your deep map? And so this is an area where you can whiteboard this out. You can kind of think through things, and it'll help you organize your HSDI instead of it being a mess of databases. Next slide. So we're going to focus on the social environment stage primarily today. That's where a lot of our effort kind of went into building the Q and a time traveler, as you probably can already see, although it's not the only one. The built environment was very important as well, and that kind of came first. Next slide. So moving into part 2 here, I'm going to focus on creating these stages and how we actually put them together in our case. We're going to be doing a lot more hands-on work with this during the in-person institute and going forward virtually as well. And so this is not a blind recipe for you to follow, but hopefully this raises some of the key data issues that most of us will encounter and gives you some insight into how we solve those in the context of building this HSDI. And of course, we're really eager for you to think of things we haven't done, or maybe nobody has done in a lot of cases during the course of this institute, to really kind of push the boundary of the state of the art. Next slide. So as I said before, we're going to focus mostly on the social environment stage, but before we did that, we needed to build a framework, a spatial temporal framework for bringing spatialized demographic data into our social environment stage. So the built environment stage reconstructs the physical human-built landscape in the past at those decadal markers to the best of our ability. And in our case, we focused on these sort of urban areas within our project area because that's where the best cartographic information lived, particularly these fire insurance plans, like you could see a screenshot in the middle here of. And we built building footprints and some other landform type of things, some other environmental components that actually provide spatial anchors and temporal anchors. They live in a certain space and a certain time, and you can then attach data of other kinds to them. So this allows us to link data together. It allows us to situate data in space and time. Next slide. So this is the workflow for doing that. And so this is kind of the nuts and bolts of the major steps that we took to create that. We started out by acquiring the cartography that we were going to use. So we mostly, again, relied on those Sanborn fire insurance plans, but this could be any cartography or aerial imagery that you're starting with. And where it was not in digital form, we digitized it. And we also rectified it, geo-rectified it. So we put it into its spatial coordinates. Those are those first 3 steps there. And you can see on the bottom here in brackets, I listed some of the basic software packages we used to do this. So it wasn't a large number of software packages that we used to achieve this. This is slightly simplified. But at the beginning, it's, again, just using good quality scanning software. And then a lot of the heavy lifting is done in a GIS software package, in our case, ArcGIS Pro, and a little bit ArcGIS Online. But you could do these middle steps using open source GIS software like QGIS, MapWarper as well, and some other kinds of online GIS software. But that green stack is where we actually built those building footprints or other environmental components and added the attributes from the historic map. So what are the addresses? What are the building materials? What are the sort of labels on the map that tell you information about different buildings or other features? We bring those all in and attach them to those vector shapes that represent the built environment and store that in our HSDI in a particular geodatabase. Once you've done that with one time slice, you can then repeat the same process with multiple time slices. So our built environment stage over there on the right lives in that enterprise database, geodatabase, spatial database environment. And so the built environment stage is a collection of groupings from different temporal scenes of the necessary data sets that form a reconstruction of a past landscape, and also containers or places to connect other pieces of data that are relevant in some way, either because they share a spatial location or some other relationship. Next slide.
Yeah, and I'll just say quickly that the the green sections there are going to be both asynchronous workshop that we're just about to release to you guys, as well as something we're going to spend time on while we're together in July as well. So best practices about how to set up a workflow for this, especially if you're working with volunteers, public public volunteers or groups of students, or other groups that are going, it's not just you guys sitting down and building these things out, but you're going to have groups of other folks working with you. We've got some standard practices for trying to alleviate heartburn in doing that, and how to make sure that you can vectorize whatever environment you're using in a way that allows you to also do some spatial analysis with it, rather than just being sort of a visualization, but also allowing you to do some actual analysis with it. So again, that's for future workshops.
Yeah, and just to sort of add to that really quickly, some of the stuff in here is definitely old hat for some of our fellows. Some of this is new. And again, going back to what an HSDI is, the scalability of it, you can do this on a very simple level using very simple software, or you could do it on a very high resolution level. You can do it at a large scale spatially. You could do it at a very small scale spatially. You could do one block of buildings in a town. You could do an entire state using the same workflow. It basically just boils down to what is your scale that you're trying to achieve? What kind of data sets are you starting out with? How much time and resources do you have? So this is a flexible workflow, and it's sort of simplified, but it should cover pretty much all circumstances for building your built environment. All right, next slide. So once we have that, we built our social environment afterwards. And you could kind of do these in reverse, but I think it would be much more difficult the other way around, because with the social environment, what we're looking for is information about people and populations that has some kind of spatial reference to it. And that could be something like an address or a building or a workplace or an institution or a neighborhood or something like that. And so when we already have those things created in our built environment, it makes it a lot easier to think through the kinds of records about people that you could add to your deep map with relative ease. Sometimes you'll come across a record that doesn't fit into your existing built environment and you have to expand or modify your built environment. But if you have thought through the process enough in advance, you usually have a good spatial container to absorb all this stuff. In our case, the key social environment stage data sets that fed into this were, of course, the census, other similar but smaller scale records like employee and school records, which are illustrated here, that basically attach a large group of people to a particular school or workplace. And so they were all relatively similar for the most part in that sense. But there's a few other data sources like diaries, narratives associated with individuals or groups, other kinds of primary source material like oral histories or recordings that can also be brought in. And they're handled a little bit differently because of the kind of media that they may be. Because if you look at these ones on the screen right now, these are sort of these tabular records that have categories, and they're very easy to turn into a spreadsheet or a database form and ingest into a database in the HSDI and then connect to other things. The other things like diaries are a little bit more challenging potentially, but they're also consumed in a different way by users. But bringing all of these in, if we go to the next slide, looking at our workflow in this case, and this is kind of a census example, but pretty representative of these tabular data sets, these official record sets for the most part. Again, I've shown you some of the major software packages and brackets that we used here. And there's three major steps on building a social environment stage. You have your digitizing and cleaning stage, where you're preparing the data to be used by software and ingested into software. You have your mapping. So this is where you connect the social environment data the born paper or born digital data set to those spatial containers we built in the built environment. So those building footprints or streets or neighborhood boundaries or whatever you have built. And that's through a process called geocoding, which we're going to talk about in a second. And then Don later is going to talk about the linking phase, and that's where you take your data that has now been ingested digitally, it's in a database, and it's spatialized and connected to our digital framework of the built environment, and then link it to other data sets. And so that's where you have a situation where you're, for example, linking the census data to school record data so that individuals that are represented in both data sets become linked within the HSDI. And that's where the HSDI really starts to show its power. And we're going to talk about that a little bit more later. But again, this is kind of one social environment stage workflow. So you get one of your sort of time slices by doing this multiple times with multiple data sets from the same time slice. And again, this is a digital way to reconstruct a social network. That's essentially what we're trying to do here. We're trying to build a neighborhood, a class, a group of coworkers, a cohort of people who have something in common, whether that be sort of religious affiliation or ethnicity or something like that. By building these things up and bringing all the data in digital in a way that is easy to manipulate and search and find, we can reconstruct those networks using the data at hand by linking them together. Next slide. And as we kind of show here, this probabilistic record matching is something we're going to do in our in-person workshop, and we'll work more with that going forward after that as well. So we're going to talk about the linking itself, but we're not going to go into the nuts and bolts of the record linking or record matching. That's sort of its own animal, but we'll get there. Okay, and then thinking more broadly, I've given you two examples that were key to what we did, but you shouldn't confine yourself just to those stages. And I'm sure you're already thinking of other stages that you're going to be building, and some of them might be key to your own projects in a way that's different from ours. One that we've kind of thought about that is, it exists, but it's still one of the ones that's very much a work in progress, is an industrial stage. So this is a different theme from just your basic built environment or social environment. This is recognizing that our project area is an industrial landscape. It's a heritage landscape now, but in its sort of historical heyday, it was an industrial landscape. So what does that mean for a deep map? What kinds of data sets exemplify the experience of an industrial landscape, the people who lived in it? And we thought about things about recreating the massing and scale of industrial operations, many of which are gone now, have been demolished or very heavily altered. So we did things like this 3D reconstruction of the Quincy copper smelter, which is largely still standing, but we can add in missing buildings that have been demolished or burned down in some cases. So this is something that's in addition to the built environment stage because it focuses on these industrial scales. And that really kind of boils down to thinking bigger. So networks of trade, networks of business infrastructure that go beyond our region. So this would be something ideally that would stretch down into the lower Great Lakes where the products of the mining that happened up here were actually smelted and turned into final products. So this would be this is a conceptually different kind of stage from the other two, but it can interact directly with data from those other ones as well. And they sort of build on each other. Next slide. And of course, again, thinking more broadly, what kind of stages are you potentially considering that might build on that or be useful to you? This kind of circles us back for a moment for why we're doing this. We have this built environment data. We have this social environment data. Most of the GIS-based history-focused projects that you see, these spatial projects, some of which are even calling themselves deep maps or have been referred to as such, often use modern data to get things glued together. So we think about using a modern map or a modern address locator, so a list of modern address locations that you can then map historical data to. And that's really quick and easy, and you could do it on a really, really large scale. You could do it on a national scale, frankly. And so you can put all these historical pieces of data into their historical location, but it doesn't quite work the way we want it to do. It doesn't bring the kind of fidelity and accuracy that the system that we've put together does. So this decontextualizes historical data or juxtaposes it with modern data. And for one thing, it means the user has to start keeping track of what is modern and what is historical and look at discontinuities between those two data sets because of subsequent change over time. And so this is something that is being done now and it has its place, but we're trying to go beyond this. And that's specifically why we developed the HSDI. Next slide. And so again, contextualizing things in these historical spatial containers. So matching historical data with historical spatial data, and also interacting with them as a group as much as possible, not just using them as static sort of backdrops or illustrations. We want this to be alive as much as we can. Next slide. So here's one example of why this is a good idea. And this is something that even we are still working towards, but it's good to have goals, especially ones that are kind of still well ahead of you. And this is one we're still working on, but I think is an essential future goal for deep mapping. You can have this data illustrated on this map. You can digitize it. You can put it in a database. You can map things to it. But ultimately, this allows us bringing these different data sets together and digitizing them in an HSDI allows us to think about qualitative descriptions in historical texts or oral histories and find them in our data sets. There's no finished barbershop next to the drugstore label anywhere, but there is a barbershop next to the drugstore. And if we're in the right space and time, we can find these things. We can begin to map texts and narratives or documents or oral histories using some of these qualitative descriptions. And that only happens when you bring multiple sources together in a flexible way that allows them to be investigated both by humans and through software. Next slide. So that's kind of the nuts and bolts, the construction, the backbone. And again, we're going to go through that during our in-person seminars in much more detail and give you all a chance to actually work with this stuff with us there. And we can all talk through how to do that for yourself and what advancements you might even be thinking about or different directions you might be thinking about. The idea is a framework that's flexible enough to accommodate growth and change and innovation, frankly, in this kind of method. I'm going to zoom in a little bit now for part 3, and I'm going to focus on how we actually spatialized our census data. And so this was about taking the built environment, the human built environment, and then populating it by spatializing these demographic records. And so this is the geocoding phase and the data prep for that, and dealing with the kinds of issues we commonly have with historical data sets. Next slide. So this case study is focusing on the census data, the US decennial census, which in our case happens, as the name implies, every 10 years. And this was data that we got from IPMS. So this is the premier source of US census data. This was a really long project in the making. So we don't want to discount the fact that it essentially took decades to build this before our project even got started. We're taking advantage of a lot of digitized, spatialized demographic data that we had available to us. You might have to start with paper records like an original census form here over on the right. And so that data would need to be digitized first in that case. We're going to kind of skip over that because the IPMS data was digitized. But I think the discussion of data issues here will kind of encompass that step as well. And so you can imagine the kinds of things you'll need to do in that case. We all know that historical data is not clean. It's not straightforward. It has all kinds of different issues that are inherent in studying history and studying evidence of the past. So you run into these standard issues of, can you actually extract the information from the source with accuracy? Does it cover all the things you're trying to cover? Who was creating that record and why did they do it? And how will that impact the quality of the data or the way that the data is represented or recorded? What is left out? What might not be accurate? What might exhibit a bias? So those things do very much impact and affect the way that we that we ingest this into an HSDI. That process is really important because you do it once and hopefully you don't have to mess with it again. You've done it in a way that is thorough enough that it can then be used or added to. Next slide.
Excuse me, I'll just say that for all the US and Canadian teams, we've got, we can help you if census data is part of what you want to do. We can help you gain access to this data set. We've got a similar one in Canada, in addition to the one that IFMS has for the US. So
Yeah, thanks, Don. And this is something we've spent a lot of time working with. So this is kind of our primary case study example. But again, this is applicable to other kinds of data sets as well. Um, So our focus here was not to just map the census data, because you can actually do that right out of the box with US Census data, but you can only do it to fairly gross geographies, things like counties and stuff like that, maybe cities if you're lucky. We wanted to get it to the individual level where people lived, dwellings, workplaces, things like that, the maximum, the finest possible scale that you can get away with. Um, but there's some major obstacles to doing that right out of the box with this census data, even though it's been digitized, transcribed, coded by IPMS. So they've done a lot of work already, but there's still a lot of work to do when you get to this point. Just as a quick example here, up to 40%, depending on which year you're looking at, which census year, of the records in the census just don't have street address data. So there is no address at all. In the 1880 census, for example, there were only 2% of records with address data. And even of that 2%, not all of them were complete or usable addresses. This is literally me just looking at the census tables and looking for empty fields. So empty means there's nothing. We're not going to be able to do anything with it from this particular part of the data set. So that's one initial substantial obstacle. Next slide. Um, when we deal with that missing historical address location information, we're also dealing with an urban-rural divide as well. The 1880 census in the US was the first one that started collecting that kind of information, and most the censuses afterward have a much higher proportion. Um, but this is much more regular and reliable and complete in towns, which you can see notated in red within roughly our project area on the Keweenaw Peninsula here, than it is in rural areas. And again, in our case too, this was an area that was being settled by Europeans for the first time at this point, on a large scale. This was during a mining boom, and there were agricultural areas developing alongside the mining areas, but they're just not mapped the way that fire insurance plans in towns are. And the coverage that we have here is extremely spotty outside the towns. So that's a major challenge as well. Next slide. I'm going to run through a couple of challenges that happen within the towns, though, because those are still not smooth sailing. We have these really nice fine scale maps. These are basically the best historical maps you can generally expect to find in any kind of historical research. And yet, because of the nature of the community and the way it developed, and the limitations of the maps, and some of the general issues with historical documents I mentioned earlier, you still can run into some fairly thorny problems in terms of trying to find places to put census dwellers in these maps. And they're constantly sort of, as Wright mentioned in the chat here, IPMS is improving their data. So that's something to recognize. They do things to clean up and improve their data over time. So, you might find that you work on something for years and they maybe fix it later. But generally speaking, when you get the data, you want to be able to do as much with it with yourself as you can. So dealing with these issues, in this case, for example, we had a block of tenements, and this is actually not that far from where I'm sitting right now. I live in Calumet. And so this was a really fast growing town back in the early decades of the 20th century. And you have this really confusing addressing system that springs up as buildings are quickly built to accommodate the growing population. There wasn't time to really plan things out, to neaten things up, even to correct mistakes in some cases. So when we have people living at 413 or 414 or 415 address here, in this particular case on Pine Street, I think it can be really difficult to impossible to figure out where someone actually lived within those buildings. We can narrow it down to the couple of buildings, which can be helpful, but we're trying to do better than that. And there's also duplicate addresses in some cases here again, so you might be confused by where to put people because you have the same number. Next slide. Here's another one that was lots of fun. On the right, we've got a couple of addresses on 8th Street in Calumet. So we have 217A at the bottom and then 217B at the top, but 217B has 217BA and 217BB, which I can assure you was never recorded in the census that way. So the map is sort of differentiating certain addresses, and the house on top is a duplex, so one building that's divided for two different dwellings. But this can pose some serious problems about where to put someone when you're setting up your mapping software, your geocoding software. And on the left, we've got 209, 209A, 209A and a half, 209A and a third, and then down at 209, another dwelling that doesn't have an address attached to it, which may be considered to be on the street on the right, or maybe it's coming in off the alley on the left. Not sure. So we have several different forms of uncertainty to deal with here. And once again, in my experience, the census doesn't record a lot of these suffix addresses. It does a substantial number of them, but many of them not. So you don't get a consistent quality of data in historical sources, as we know. And this is an example where that causes specific uncertainty issues. Next slide. Here's one that drove me nuts. I remember this one. We were working, this was like during lockdown when I was geocoding this one, and we had two 410s, and there was no difference. It wasn't a 410A or 410 and a half. It was 410 and 410 on the same street, across the street from each other. They were two-story commercial buildings with dwellings above. So literally no way to tell where people lived between the two. You know, and again, you might say we're still getting a good spatial resolution by putting them in one of these two buildings, and that's true. But as we're continually trying to improve our methodology, we're trying to find ways of figuring this out. And of course, there is a differentiation. One's a boarding house, one's a billiards hall. So we might be able to find some information in other record sets that helps us solve this issue, which is why we're recording all this data when we digitize it. You'll also notice that 410 on the right or east side of the street has its usual 1/2 and possibly a 1/3 back there as well. So multiple potential duplicates in this case. Next slide.
Yeah, and I'll just say that these are not just idiosyncratic to our particular region here. I've done these projects in Victoria, BC, and in Montreal, and in London, Ontario, and any of these industrializing city. Anytime you've got a lot of either immigration or industrialization, you're going to see these kinds of patterns in addressing in cities. So
yeah, absolutely. So those are some issues that we're dealing with that come from our cartography, our built environment, that they both show us that there's more detail that we need to consider when we're mapping, but they also raise the bar for being able to put people in their dwellings. And sometimes the census meets that bar and you've got some of that tricky address information. Some census recorders were extraordinarily diligent and they put people in 410 and a half. And even maybe it says billiards hall owner or something. So we may get the information we need to map that person, but we now need more than average amounts of information to do it successfully, and it's not always there. Going back a second, if you start with paper records and you do your own transcription, you're going to have to think through how that transcription process is done. Are you going to capture everything in your paper documents? Are you going to use a semi-automated process with software, or are you going to data entry the whole thing by hand? And that process of digitization really does impact the final product. In our case, in this case, with IPM's data, the census data, this was transcribed over a long period of time, typically from microfilm scans by non-expert volunteers. That's important because these are people who, number one, never lived in our area. They knew nothing about where we lived. They weren't necessarily historians. And they weren't necessarily super familiar with the census before they were trained up to do the transcriptions. So while the IPM's data does set a pretty good standard for high quality digitized large scale historical data, it has its limitations. And this transcription process, this digitization process, going from a microfilm scan of the original document, which in itself can degrade the quality a little bit, we have transcription errors. We have situations where the street name field doesn't have the name of the street in it. It has some other kind of useful, but not 100% appropriate for that category information. The census taker couldn't put a street name in for some reason. Maybe they were at a mine location that had dirt roads that weren't named. So they did the best they could and they put something in like Quincy Mill location for a copper mill. Or they mentioned a place like a hotel or said it was off a state route. Maybe it's a rural property. So this is useful information we don't want to abandon, but it's not going to feed directly into an address list that we can map people to. There's also a situation where local knowledge becomes really important, and if the transcriber didn't have it, it produces some odd results. So we have in our data set, in our streets up here, names that are associated with mining, like trammer, jacker, amygdaloid, ingot. So those are geological or mining technology terms, and streets were named after that because this was a mining district. We also have indigenous languages that are used to name streets. So Calumet, Powabit, Keweenaw. And those are not only indigenous languages, but they're probably anglicized corruptions of indigenous languages. So someone not familiar with the area won't know what those are. And when they see a cursive Keweenaw, they have no idea what that is. They'll do the best they can to transcribe the letters, but someone like me looking at it, I could look at a pretty messy Keweenaw in cursive and know that's what it is because I live up here and I have that local knowledge. And so when you're dealing with this census transcription data, you're going to see a lot of errors that you might be able to actually fix, but the original transcriber would not have the information they need to accurately transcribe it. I've also run into a few maddening situations where whole columns were transposed between each other. And if it was done in a subtle enough, accidentally subtle enough way, they can be hard to rectify or even identify. And so you have to make sure that all the correct data is in every column the way it's supposed to be, and it's not shifted or something like that. And so again, this would be a first-rate data set to work with, and yet they still have all of these issues. Next slide. Another one, I brought this up earlier, was this inconsistency between rural and urban areas. We just have more and better data in towns, and that's always the way it's going to be. That doesn't mean we're not trying to improve our precision outside of towns, though. But we need to consider the kind of data we have to work with. So in the case of our study area, there were a couple of county roads that ran up the peninsula, and a lot of people lived near those. But there were also a lot of rural roads and tracks that weren't even really on maps or anything like that, that people lived on as well. And so there was no specific unique descriptor that you could put in the census to identify exactly where that road was, or indeed an address on it, since there was no addressing out there. And so you can get the list we see here, very common, where there's just hundreds of people listed under farm, rural road, county road, something like that. Maybe even one of the survey section numbers. So when this area was platted by government surveyors, they knew which section they were in and they just put the section number because that was actually the best identifier for a location that they could come up with at the time. So this is what we're going to have to work with. So if we want to improve this resolution in the future, we're going to have to think about ways to take this information and make the most of it. Next slide. So those are our issues. What was our solution? And the idea here was we're not going to be able to do this with a one-size-fits-all situation. We're not going to be able to build one scale and then map all of our data in our deep map to this one scale. We want it to be like the dwelling where people live. We can't just demand that everybody is in a dwelling or they're not mapped at all, because then we lose far too many people. And a key essential goal of this project was to make sure that every single individual in our data set was actually mapped somewhere useful. And so after doing a little bit of thinking, when we were brainstorming this and developing our initial deep map project, the solution was to build a hierarchy of scales, multiple geographic scales that are kind of nested or stacked, and also serve the function of sort of transparently illustrating uncertainty in the data. So we came up with this system of 4 in the green here at the bottom, which are finer scales than the one in the blue on the left, which is the data that's built into the census. So when you get the US Census data, all of the people that are in the census will have a state and a county, at least, sometimes a city, indicating where they were, and also their enumeration district. But none of the data is actually ready to geocode or map to finer scales than the stuff in that blue box. And so we found these four that we could map them to. And instead of picking one or coming up with our own, we decided to just do all of them. Because everybody in the census should be able to be geocoded to one of those four scales. And the idea here is you have this increasing precision. So if you can't map them to a building, you can map them to a street. If you can't do that, you can map them to a settlement, which we'll discuss in a minute, et cetera, et cetera. And so you can see as we're going towards finer geographic scales, less uncertainty in the data, more confidence that the person actually was in this spatially discrete, more precise spot. So these are the four that we picked for this particular workflow. And again, the idea is to ultimately capture 100% of the census. Next slide. So the workflow to do this, and again, this is where I'm kind of talking nuts and bolts, and this is stuff we'll work on more in the in-person and in subsequent phases of the Institute. I came up with we collectively came up with a 6-phase workflow, which basically starts with doing some of the data cleaning that addresses the issues I've been talking about for the last few minutes. And then the next 4 phases after that are geocoding people to increasingly larger scale or grosser scale geography. So try the best one first. If that doesn't work, then whoever's left goes to the next one, and so on and so forth until we have them all mapped. And then in the final phase, we actually do the final cleaning and packaging so that this data can then go into our HSDI, into the social environment stage, and is ready to be linked with other data sets, illustrated, mapped, included in our final software and websites that people can access. Next slide. So the first phase is actually the longest one, and it has a couple of components. The first part of that was actually reconstructing the enumeration district boundaries. So in the US Census, all of the geography is broken up into enumeration districts, which was simply the area that the census enumerator, the person recording people, would actually be confined to collect their data. So they broke up the landscape into different enumerators zones, and they enumerated all the people in those districts. In some cases, we actually have maps, like in the lower left, of what those were, although they can be sketchy. In other cases, we don't have maps and we just have textual descriptions, like the one above the with the Red Jacket Village part of. And that can refer to things like buildings or roads or even trees or fences or things like that. So what we ended up doing was actually going through these handwritten maps or these textual descriptions and reconstructing them manually, kind of a painstaking process to redraw these boundaries digitally and add them to our HSDI. And this was a really key step. And this is a step that still presents a challenge for all kinds of different geocoding of demographic data today. A lot of people are trying automated ways of doing this. And they're ending up with essentially enumeration districts that are not hard boundaries, they're kind of fuzzy and not as accurate, but it can be done with artificial intelligence and machine learning. Our method takes a lot more human work, but it is far more exact, I think. We end up with a much more precise enumeration district boundary. And so that's one container that we can geocode people, we can map people to. Next slide. The next one, and perhaps the most eye-searing one from the point of view of the researcher, is actually manually cleaning that IPMS address data. So this is where a lot of those transcription errors and other things can be corrected, particularly by someone who has expertise in the project area. So all of your projects focus on areas that you study. You have expert knowledge about those. If you're looking at data pertaining to them, you are far better than any other person to be able to make sense of that data, identify errors and inconsistencies in that data, and correct it. And that's what we did in this case. We looked for obvious spelling errors and things that we could make global corrections to relatively quickly. Things like address corrections, transposed columns could be fixed. I could flag information in certain fields that was useful but not directly applicable to our current work. So vague geography references, I could flag all those so we can go back and check them or convert them or work with them later. And then reformat these tables for geocoding. And so I did this manually with all 300 and however many thousand plus individuals we geocoded in the census for our project in the Keweenaw Time Traveler. And each one of these decennial census years at the time we started working on it took me about a month to do, and it took about a solid week of work cleaning up these tables, which was laborious in the extreme. But it did pay big dividends down the road. And we also used some semi-automated approaches when we could for cleaning up and correcting data. Next slide. So for phase two, we're actually starting to put people in place. This is the nitty gritty. This is the mapping of census individuals. We ended up with over 116,000 building footprints over our roughly 1880 to 1950 project area and time period for the Keweenaw Time Traveler. And we then actually took that building data and built tables of addresses that related to each one of those polygons, those shapes, those building footprints. And so that is our digital map, our digital container for placing people. We can match individuals based on address to specific buildings after having built those building footprints. We actually had, like many towns in America, some unimaginative naming conventions. So you have two towns next to each other with an Elm Street or something like that. And so in order to correct that, we would actually build a single address field that included the house number, the street name, and that enumeration district boundary that I built previously, that would allow you to basically map people to the correct town, even if they have the same address in a different town. So it helped with duplicate street names between towns and things like that. But this is sort of the gold standard. This is what we want to do, is map everybody to all the buildings, get them into their actual dwelling. Next slide. But not everyone goes there. Again, talking about all those issues we had. So we actually built a street layer starting with a freely available state-served GIS open data street layer, and then modifying it to conform to our historical maps so that we can make sure it was accurate, period accurate, in terms of both the streets themselves and name changes over time. And so if people had a street name in their data, but not a house number, so we couldn't put them in their house, we could actually put them into the street that they lived on within the enumeration district that they lived in. And so in this case, we built centroids, center points of the street. So instead of putting people along the street, because we don't know exactly where they were, we put them in the center of that named street in the place that they lived. And so this was the second level of precision that we can map people to. Next slide. The next one was a little bit, required a little bit more thinking, because we couldn't get everybody in the streets either, but there were other places of significance and other labels of places that could help us. There were a lot of locations that were mining locations, or civilian conservation corps camps, or towns that no longer exist, or settlements that never became incorporated, but exist in the historical records and still the sort of memory of the current population. And so going through large volumes of old maps and data sets that actually have place name references and reconstructing where the locations of those places were, we could build a map of a more precise location than an enumeration district or a county or something like that, an actual settlement, as I called it, and put people there. And so this is a difficult to define concept. It's flexible. It could be any sort of community that had meaning to the people at the time. And so rather than trying to give it a very discrete geographic definition, it's a little more flexible in that regard. And we went through and mapped as many of these as we could find in the records, particularly in the census data when it listed a place that wasn't on our maps, but hundreds of people lived. Let's go find where that was and map it. We ended up with 164 of those settlements in our project area that we could geocode, we can map people to. Next slide. And then finally, the remaining people that couldn't be mapped to those first three went to their enumeration district, because everyone has an enumeration district number in their census record. So this was the catch-all that got us some data as a sort of plan B if nothing else worked out. And this is still more accurate than a township or a county or something like that. It puts them in a more discrete geographic location. And you can see some of these enumeration districts are smaller than others. The ones in the towns are pretty small. The ones in the rural areas are pretty big. But if you have maps or particularly aerial images, you can often see where people are living within those boundaries, and it further really narrows down where people may have lived. In this case, we just chose a centroid for it to be consistent, and if the centroid happened to be in the water due to the way the boundaries were drawn, I kind of moved it onto land. So it's a little bit more representational, but it's still a finer scale than any previously available in that case. Next slide. So finally, we took all those, we merged them together, we exported them into our HSDI in a database, and we published that in our portal and connected it to our other data sets. And I then went back and did it 5 more times with the 5 remaining censuses. And that's how we ended up with our 340, 350,000 or whatever the final number was. Next slide. Speaking of numbers, 379, there we go. I should remember that. But this is kind of where we ended up after following through on that process. We had 17.29% overall geocoded to buildings, our gold standard. And then we captured many of the remaining ones in the street. So those two are a really, really good precision. The settlements provided us with locations for populations that otherwise really don't show up because those settlements aren't on the map. They're not easily mapped to, or they no longer exist, or they're referred to by multiple names. So that brought a lot of people into a meaningful place that descendant communities or historical texts would refer to directly and we can connect with. And then finally, everybody else was in an enumeration district. So over half of them were recorded to a finer scale than that enumeration district, which is itself finer than you get with the standard census data. I should just add at the end here too, that when we had a valid street name, between 88 and 96% of them actually made it onto a street. So all of the people beyond the streets in the settlements and enumeration district categories, that was almost always because there was just 0 address data in their field. There was just nothing to work with. So we had to work with something else. And then here's what it looks like when we're done. This is the Q and a time traveler that you can use today that you've all looked at. And so it's feeding those census data fields into our software and showing where we managed to geocode them to. So people in dwellings were the ones geocoded to buildings. People out on the street were the ones that geocoded out onto the street. And then in settlements, they're kind of in the middle of the settlement, to the best of our knowledge, in the middle of the enumeration district. Next slide. In the Hamtramck historic spatial archaeology project that we've also shown you, we did something a little bit different. Instead of mapping people, we're actually mapping archaeology data. And this is a project that's still being developed. So we're going to add the people and follow that sort of census geocoding protocol. But you can do this with different types of data. It doesn't have to be individuals with the census. It could be material culture from archaeological excavations. It could be buildings that conform to a certain style of architecture. It could be anything that you can map on a historic landscape as a class of object or manifestation of something. And of course, you can connect to it things like 3D models, as we did here with the archaeological excavation. So photographs of artifacts in a database and also 3D models. So this isn't just about another way to map census data. This is a way to map anything. Next slide. And with that, I'm going to turn it over to Don, who is going to talk through a case study about the advantages of linking this data together, which is something we'll talk about in greater detail in our in-person seminars.
Yeah, I'm going to make this pretty quick because I want to move on to some other parts of the workshop today. But I do want to give you kind of a concrete example of why it's important that we build our deep maps using an HSDI type approach, and how that really allows us to be deep, both in time and space, in the way in which we connect both social and spatial and temporal relationships of people. In this case, again, I'm going to show you people through time. The key feature is that all the data in the HSDI is interconnected and connected to some series of social or spatial relationships, and that some of them persist temporally, some of them don't, right? And that you can, through this, you can follow movements of people through space and time that can be tracked along with their changing demographic data that we observe through the different sources. And so this is where it becomes really problematic. When we try to follow people over time, names are changing, their geographies are changing, their familial relationships are changing, their occupations are changing. But if we build them in this type of way, we can start to fill in those gaps and be able to link people that we otherwise can't use with traditional sort of record linkage approaches. So I'm going to walk you through, as an example, a family. Okay, so this is just a family that we sort of picked out of our data sets that Dan was describing. We're going to start here with Nicholas Chop. He's a Croatian miner. He immigrated to the U.S. in April of 1882, or 1892. I'm sorry, and likely to Ellis Island, based on what we can see on an employment record here. We see he's making $4.80 an hour when or $4.80. Sorry, when he started his job in 1901. So this is just a person that we start with, right? From there, so this is a zoom in of an employment record, for example, we have for Nicholas Chop here. We can see all these details about when he immigrated, where he immigrated to, his date of birth, where he was born, his current residence, and some information about his work. He's a trammer and a miner here, okay? We can then link that 1901 record to the 1910 census. So here's the 1910 census. He's listed, however, in the census not as, it doesn't say Croatia, Austria, it says Austrian, Slovenian, for example. And we can see that we get a little more information about him. We see that he rents his home now at this point. We can then link it to a 1916 city directory. We can see that he now owns his home by 1916, so it gives us a little more information there. And despite spelling inconsistencies, we have enough other data there, in this case, address, to be able to know it's the same person. To the 1920 census, we can see that the last name is spelled quite differently, spelled C-H-U-P versus C-H-O-P-P. The ages are slightly off, and the birthplace is now listed as Yugoslavia, but because of the rest of the familial relationships, we know that this is the same person. And I'll keep walking you through this, just see how these come together. A year later, we see that Nicholas gets laid off. This is here from an employment record from 1921, that he was laid off on the 1st of April. We see that he's receiving payments from the Employees Aid Fund, for example. We can then link it to a 1922 employment record, where we see that he was rehired later that year as a timberman, now making only $270 rather than the $4 something he was making before. But we also now have some biometric information about him. He's 5'6", 193 pounds, blue eyes, gray hair, and 56 years old. Okay. We also see that he quit a year later, almost exactly a year later. Okay. All of these records, for example, are able to be linked because of a common spatial relationship. So it's the spatial links in this case that allowed us to link all these different sources together that have otherwise disparate types of information. And without that spatial link, we may not know this is the same person. Okay, in some cases it looks pretty obvious, in other cases it's not, right? And we do this through a semi-automated probabilistic record linkage algorithm that we'll be teaching you guys when you're here in July. The spatial links improve accuracy. They isolate those spelling errors, the age discrepancies. They help rectify some historical geopolitical events that are going on and help us overall increase the knowledge of the historical populations in which we're trying to study. To finish this example, for example, by 1928 in the city directory, we find him now as an auto worker down in Highland Park, which is an enclave within Detroit. Okay, and we can map him to that location on Bonavista Street in Highland Park. By 1930, we see his birthplace is now being recorded as Austria again. Again, just dealing with those geopolitical name changes over time. And he's now working at Ford's Hamtramck plant. By 1940, oddly, his birthplace is being listed as Estonia. Everything else tells us that it's the same person. He's now retired and he's at a new address in Highland Park on Pilgrim Street. Okay. And And so it's this diversity of sources that allow us to be able to follow an individual through time, fill in the gaps in the historical record that one source alone wouldn't be able to tell us, and also place them in our built-in social environments. We can do the same thing. I'll do this very quickly with the family. Okay. So this is, for example, this is the 1920 census. We know because of links to the 1910 census that Nicholas, Charles, Mary, and William are parts of the household, even though they're not listed in the 1920 census household. Okay, but because we can link the households over time, we can fill in the gaps to understand these folks were at one point part, or not part of the household, I'm sorry, part of the family. Okay. This backward mapping, that deep mapping going backwards allows us to fill in some of these gaps. So here's a couple examples, right? We know Nicholas Chop, he was 13 in 1910. He was listed as city director as an enumerator in 1917. His draft record from World War I says he was a painter, and then he's not in the family in 22, when he's 22 years old in the 1920 census. Maybe he's off at war, right? We don't, or died at, we don't know. Charles, we can follow through because of school records that he was in the Washington school 2 years prior to the 1920 census. Okay. Mary, the daughter, we find in the school records in 1912, but we don't see her in 1920. She could have gotten married. We know following married women can be challenging without a marriage record. Maybe she passed away, we don't know. And we can do the same thing with some of the other siblings and follow them across time. Okay. We can then go backwards as well from there, adding in things like birth records for some of the kids. And with all of these different records, we have lots of different linkages. So just in this one family, starting with 2 census years, we can link the family through all these other sources in all these different myriad of ways. Okay. And that's really the power of what we're trying to talk about here. This is just another example going forward in time from 1920 to 1930. We can see that Nicholas, while he wasn't in the family in the 1920 census household, he's back with his parents as an auto worker in 1930. Same with Charles, doing the same kind of thing. William, who was 16 prior, now owns his own home, is married, has a couple kids, but is linked to the family record. So you can just see different ways in which we can fill in the historical record of these individuals through record linking these different disparate sources. Okay. We can also look at neighborhood social environments. So this right here is the Chop home that they lived in for about a 20-year period. And all of these red ones here were the Chop children's neighborhood friends who also attended the same classes as they did in the neighborhood school. So we can see those different types of spatial relationships. Okay. We can also look at the broader school environment. So here's the school that all those kids went to, and here's the industrial environments in which the school was placed within. Okay. And we've talked a little bit in the Time Traveler about the importance of storytelling and sharing, having the public work with us to share these stories. These are examples of different stories that I just flip to them really quick of other individuals who were connected to the Chop family, and that just members of the public submitted in the Time Traveler. Okay. Okay. That being said, I'll turn it back over to Dan to walk us through the next part of our workshop.
Alrighty, so we have reached part 5 of 6. As homework previously, we sent you some links of some projects to discuss, and these are projects which embrace various aspects of deep mapping, and they have different purposes, different strengths and weaknesses, different sort of technologies they use, and all of these projects, represent mutual inspiration to people doing this kind of work. And so we wanted to throw a few up there that are not like ours, that give you the opportunity to think a little more broadly about the kinds of project that you're all doing, and what ways you might deviate from what we did, what ways you might follow the methodologies we've done more closely, and basically critically evaluate the projects as a whole as something, again, that to reflect upon with vis-a-vis your own work. And so we threw those links up earlier. We are going to go into our breakout rooms here shortly, and discuss those. And we're going to have, I think, about 45-ish minutes, 40 minutes maybe to do that. And then we'll call you back at the end for a very brief kind of wrap up, and sort of lead into our next webinar coming up this summer. I'll be around also afterwards a little bit to answer a few questions, but the directors will be split up into one of the three, I think, rooms that you'll be going into shortly.
So I think James is going to get us put in our rooms as he's doing that. The prompts for the questions that we kind of asked you to work through are here on the screen. They're also on Slack in the general channel if you haven't seen them there yet. And we will see you all in your breakout rooms in just a second.
And if you have any questions about any of the stuff we just talked about, of course, that's part of the discussion as well. Please ask.
Okay. All right. I hope everybody had some good conversations in your various breakout rooms. I know we did in the one I was in with Krista. Some good reflections on some different things. The whole idea there was to get you to get some other inspiration, some other ideas, think really critically, but also proactively about the ways that you want to think about space and time and data linkages and the kinds of things that you're going to want to try to achieve in your own projects. And I'll just reiterate on behalf of all the project leadership team that you're going to get to see a lot of this stuff in action and get your hands dirty with your own data when you're here in July to learn how to do this stuff. Okay. So just a couple wrap up things. Dan is going to be able to stay on until about 3:30 or so to answer questions. If you have anything from today's workshop, James and I will be connecting with all of the in-person folks about a couple logistical things. So look for some emails and Slacks from us next week on that. We'll be sending you your in-person itinerary next week as well. Now that we've got, we got it firmed up as to who's coming, and we've got our guest speakers realigned with our new schedule and all of that. So we will get that to you, and of course, as you have questions, needs, etc. along the way, just reach out to us, okay? And then our next interactive time together will be June 6th when Sarah and James and who's doing it? So I can't remember.
And Krista.
And Krista. I can't remember who was leading that one. Is going to do the digital data ethics permissions and dissemination workshop. We'll also have some more digital materials coming out for you. Bob is just finishing those up. We kind of had him on a delay while we were re-scoping everything with the Institute, but now he's trying to finish those up, and we'll get those out to you on the website and on Slack. To the other directors, anything else I'm missing that we should get to everybody? Or questions from the larger group? No? Okay. Well, happy May, everybody. We're here. And for those of us in the north, it's getting warmer. So, and we'll see you all on June 6th. Thank you.